told that the coefficients of x squared and x cubed are equal and non-zero in this binomial expansion, and asked to find the possible values of n. So I'm going to assume that n is a real number. It could happen to be an integer, but I need to use the binomial expansion that's more general. And we've even got a 1 here, so it's already in the right sort of setup. This is going to be my x that goes in here. So I'm therefore going to get 1 plus 12n over 5x to the n is going to equal 1 plus n times 12n over 5x. Okay, actually, I'm not interested in that term, but I'm just going to, write out the first few terms. Plus n times n minus 1 over 2, 12n over 5x all squared. And finally, n minus 1, n minus 2, all over 2 times 3, 12n over 5x cubed. And it's the coefficients of these two terms that are the same. So I can then write down that n minus 1 over 2, 12n over 5. I'd get an x squared, but if I just look at the coefficient, then that is going to equal n minus 1, n minus 2, 2 times 3. And again, just looking at the coefficient, I can ignore the x cubed and just write this. Right, and let's cancel this down. So the n's are going to cancel, n is not 0. The n minus 1's are going to cancel, leaving me 1 there. And I can also divide through by 12n over 5 squared. So that will cancel and that will lower the power. So what are we left with? Well, a half. Actually, I can also, you know what, I can also cancel out that 2 with that 2. So 1 is equal to n minus 2 over 3 multiplied by 12n over 5. I'm going to times through by 15. 15 is equal to 12n times n minus 2. And I've got myself a quadratic. So actually there's a common factor of 3 I just noticed. So I could have cancelled that out over here, but I've just noticed it now. So I'm going to divide through by 3 to give me a 5 here and a 4 here. Therefore, 4n squared minus 8n, and then I'm going to minus 5 is equal to 0. And let's try and factorize this. So you can either go with 4n and n or 2n and 2n. Let's go with 2n and 2m. So the only way this is going to work, if it is going to work, is to put a 5 here and a 1 here. And then when I cross multiply, I'll get 2n. Sorry, not cross multiply, but multiply across, I guess, 2n times 1 and 2n times 5. And then if I make this one negative, then I'll get my minus 8n. So I'll make that one negative and that one positive. And that means that n is equal to 5 over 2 or minus a half. And for part B, we're asked state giving a reason which values of n gives a valid expansion when x is equal to a half. Now we have in our original expansion that the expansion is valid when the modulus of x is less than 1. For us, our x is this 12n over 5x. So valid for the modulus of 12n over 5x less than 1. Now I can't just get x in terms of n that easily because it depends whether n is positive or negative. So let's look at the two different cases. N equals 5 over 2 gives that the modulus of 12n, not 12n now, is it? Sorry. It's going to be 12 over 5 times 5 over 2. X is less than 1. These cancel. So I've got 6 modulus of 6x is less than 1. So modulus of x is less than 1 over 6. Now that means it's not going to be valid when x is a half. Since a half is greater than 1 over 6. So what about if that n is minus a half? Then got the modulus of 12 over 5 times minus a half x is less than 1. Now the half and the 12 are going to partially cancel, leaving me 6 here. I can actually get rid of the negative because it's inside the modulus sign. This is going to give the modulus of x is less than 5/6. And a half is less than 5 over 6. So expansion valid for x equals a half when n equals minus a half.